In any activity, visualizing your surroundings is fundamental to perception. In the age of big data, collecting information on how we do that is key. Eye tracking is a relatively new and exciting field which has become commercially available in the last 5 years. The global market is expected to grow at a 26% CAGR and result in a market value of over $2 billion. One of the companies that produces this technology is Pupil Labs, a firm that manufactures eye tracking glasses and complementary open source software. The glasses enable the user to survey the environment freely and transfers the information to a mobile or desktop interface, which can then be analyzed. The problem with Pupil Lab software is that while it provides a user interface for analyzing qualitative data, it does not offer one for quantitative data. A little more about the technology. The glasses' outward and inward-facing cameras allow testers to observe wearer behavior, such as where the user is looking, the user's eye movements, and the frame of reference as you can see in this demonstration. However, the sensor capabilities far extend that of a simple GoPro. By developing Python scripts, the software allows us to extract quantitative data points in a CSV, including visual sequence, entry time, dwell time, hit ratio, hit check, revisits, revisitors, average fixation, first fixation, and fixation count. Simply put, these metrics tell us the order of the user's movements, how long an object was observed, and how many times the user came back to look at the object. But as a CSV, the data is pretty indigestible. Our solution is to provide a data visualization software to easily view, process, and analyze the results. For example, a researcher can import their data and select the desired visualization, such as a bar or line chart. They can then edit the features of the graph before exporting for viewing and use outside of our web application. The data flows through our web application as follows. First, the lab participant interacts with the environment while monitored by the glasses. Then, the glasses send the visual data to Pupil Lab software, which exports a CSV to be processed by our application. Our application backs up the data to Firebase and then provides visualizations, which can then be used by the researcher. For the backend, we will host the application on Firebase and GitHub while using mostly JavaScript for the calculations. From our research, we found that while Python is more conventional for numeric computation, Node.js is perfectly suitable for data analysis. While the JavaScript ecosystem does lack a number of robust libraries for mathematics and statistics when compared to R and Python, the libraries do exist. You simply have to use a quality implementation. For the front end, we plan on using commonly available web libraries and languages. This includes HTML, CSS, JavaScript, and D3. Because of the way the human brain processes information, using charts or graphs to visualize large amounts of complex data is easier than poring over spreadsheets or reports. Data visualization is a quick, easy way to convey concepts in a universal manner, and users can experiment with different scenarios by making slight adjustments in our web application. As we went over throughout this video, we'll be using the following equipment: computers, Pupil Labs glasses, Pupil Labs software, Firebase, GitHub, HTML, CSS, JavaScript, Node.js, and D3. Our team structure is divided into two sections. Ben, Yuna, and Ricardo will handle the back end, while Brian and Mary develop the front end. Every sprint, we will split up the work and have check-ins to ensure the project doesn't fall behind schedule. We hope to make the interface easy to use with clear instructions, and we'll consult each other for continued feedback. With an intuitive interface and analytical toolkit, researchers can be more efficient and effective in using the eye tracking software. By creating our application, we hope to enable our clients in evaluating reactions dynamically as they observe test subjects in different environments. We hope you enjoyed listening, and thank you very much.